Many physical quantities must be described by stating a magnitude and a direction. Such quantities are called vectors. Starting at location A, the car travels across the surface toward location B. To graphically represent the velocity of the car, an arrow is drawn along the direction of motion. This arrow is the velocity vector and describes the direction of travel with its length proportional to the car's speed. Vectors are useful because of their mathematical properties. Starting at location A, the car once again travels across the surface toward location B. But while the car is in motion, the surface is moving too. The total velocity is found by adding the velocity vector of the surface and the velocity vector of the car. The sum, or resultant, of the two vectors can be found by drawing a third vector that connects the initial and final locations. In this example, the car's velocity is in one direction, while the surface travels in the opposite direction. Using vector addition, we determine that the magnitude of the velocity vectors are equal, and the net result is a velocity of 0. The addition properties of vectors are especially helpful when the directions of the vectors are not the same. Here, the surface and car travel at right angles to one another. The resultant velocity is determined using the tail-to-head method. The resultant velocity vector gives the direction of travel and the car's speed. It is important to note that, just as with simple addition, the order in which vectors are added is not important. The final result is the same.